So let's work a little bit more with standard deviation and understanding it. So what I've done here is I've created 1, 2, 3, 4. I think I have 4 made up data sets just to bring to light what standard deviation is really measuring. But let's just start with the context. So I'd like you to pretend this. Sometimes when I speak at conferences, at the end of the sessions, the people in the room are asked to fill out a survey. And just for the sake of this example, suppose the survey had 4 questions. And because the people that are there can answer the questions or not, let's just say, for the sake of this problem, that 1 person answered none of the questions, 2 people answered 1, 4 people answered 2, 2 answered 3, and then only 1 person answered all 4 questions. And you'll see I'm going to have different scenarios throughout just to kind of showcase what standard deviation is really measuring. All right, so first, computationally, here's what standard deviation does. It really takes an average of how far from the mean the data are located. The more distance from the mean, the further spread out, the bigger the standard deviation. The less spread out, the less the standard deviation. But first, we have to have the mean. And so let's start by finding the mean. So the mean in this case, take the number of questions answered and divide by there were 10 participants here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, there's 10 dots. So 10 participants. So the total of the number of questions would be 0 plus 1 plus 1. There's 2, 3, 4, 5, 6, 7, 8, 9, 10. These are 3 each, so 13, 16. And then 4 questions, that would be a total of 20. So a total of 20 questions were answered, divided by 10 participants, 10 people. That would be 2 questions per person. So again, just thinking about what average means, if everybody answered the same number of questions, it would have been 2. 2 questions for each of the 10. 2 times 10 is 20. That would have still given me 20 questions answered. But in reality, it wasn't 2 for everybody. It was 1 0, 2 1s, 4 2s, 2 3s, and a 4. Still 20 questions answered. But on average, 2 questions per person. Okay, then the next thing we do is we figure out how far from the mean are each of the data points. Let's do this in a little table. So the data, the number of questions answered, we had a 0, we have a 1 and a 1. We had 4 2s. We had 2 3s, and we had the 4. So the question is how far from the mean? That is, if we take that, we'll call it Q, and subtract the mean, 0 minus 2 is negative 2. 1 minus 2 is negative 1. 1 minus 2 is negative 1. 2 minus 2 is 0, 0, 0, 0. 3 minus 2 is 1, and 4 minus 2 is 2. Notice, when we get a negative, what we're saying is it's 2, in this case, 2 questions below the mean. So the mean is 2, so 0 is 2 below the mean. 1 is 1 below the mean. And then right at the mean, so no difference. 1 above, and then 2 above. Now watch what happens if you add all this up to get an average distance from the mean. If you add negative 2 plus negative 1 plus negative 1, plus a positive 1 plus a positive 1 plus a positive 2, notice that all that data adds up to 0. So that's not helpful. That doesn't tell us anything useful to say that the difference from the mean gives an average of 0. So what we've done, not in the MAD, that's a different thing, but in the standard deviation, we take that difference and we square it. So negative 2 squared. Negative 2 times negative 2 is positive 4. Negative 1 times negative 1. Negative 1 times negative 1. Of course, 0 times 0. 1 times 1, 1 times 1, 2 times 2. So instead of adding these up, we add these up. 4, 5, 6, 7, 8, 12. So if we add all those together, we get 12. All right? Now, we divide that by the number that there are. Of course, there's 10 participants. So if you take 12 divided by 10, you get 1.2. Now, 1.2 is the square of the differences. And this number, by the way, has a name. It's called the variance. So we would say that on average, the squares of the differences from the mean are 1.2. And now it kind of makes sense because we're squaring, we have some high numbers with the 4s, but then we have a whole bunch of smaller numbers, 0s and 1s. So on average, if all of those were 1.2, 1.2 10 times, 1.2 10 times is 12. So the sum is still 12, but if they were all the same, it'd be 1.2 apiece. It's called the variance. But that's based on squaring the differences. So to kind of get back to the original unit, if you think about this, this is the how far from the number of questions. Well, now we're squaring that. So we're talking about a squared quantity. So to get back to an unsquared quantity, we square root that variance. And that's what's known as standard deviation. And the square root of 1.2, grab my calculator on that, is let's say 1.095. And I think you see now that we use the Greek letter sigma to represent that standard deviation. All right, so alone, just stand alone here, it doesn't really tell us much. We now know that the average number of questions answered was 2, with a standard deviation of about 1.095. All right, great. Now, one thing I want you to know is to slug through all these computations, that's not really what I'm interested in so much as the interpretation, because in most cases, you are going to be given data, and the computer will have computed the mean. A computer will have computed the standard deviation, and it's more about you interpreting what that means. And so I want to share with you this tool. This will be on your exam as well. You just enter the data in here, separated by commas. So remember, there was the 1 0, there were 2 1s, there were 4 2s, there was 2 3s, and a 4. And there it is, standard deviation. There's that Greek letter sigma, 1.095. Look familiar? So exactly what we had done on our own. Up here they got the mean of 2, as we did as well. And that's the Greek letter mu, which I think you've seen now. But anyway, standard deviation and mean, we can use this tool rather than do all the computations by hand. All right, so hope that kind of helps both some understanding and making sense. Now look at this. I have a question for you. Do you think the standard deviation in this case would be more or less? Do you think the data is more spread out or less spread out? So let's think. We've got 2 of each, right? So before we had a 0, we had a 4, we had some 1s and some 3s, we had a whole bunch of 2s, almost like a normal distribution, almost. But now, 2 of each. Do you think the standard deviation would be greater or less? Hope you have your hunch. Let's go ahead and put it in. Let's put in 2 of each. 2 0s, 2 1s, 2 2s, 2 3s, and 2 4s. Look at that. Standard deviation now is 1.414. The mean of 2 still. There's still a mean of 2, but now more spread out. Now, why is it more spread out? Let's go back there just for a minute. Here we had a nice cluster. There was 4 people who had answered 2 questions. So that's not as spread out. Now, yeah, there's some 2s and 3s, but if you just look around that mean of 2, remember the mean was 2 questions per person, 4 people were right at the mean. 5, 6, 7, 8 people were just like 1 question away from the mean. And then we had the 1 people on either end. But now, in this case, still have an average of 2 questions. By the way, let's do that quick math here. 0, 0, 1, 2, 3, 4, 5, 6, 9, 12, 16, 20. 20 questions were answered still. 10 people, that's an average of 2 apiece. But now look, you've got 2 people over here and 2 people over here. More spread out. You only have 2 people right at the mean, and we have some people on either side. But do you see what I mean? That it's more spread out around that mean. And in fact, yes, the standard deviation here was about 1.414 something. So compared to 1.095, more clustered around the mean, more spread out. All right, what about this one? What if all 10 people that came to this session answered all 4 questions? Well, first of all, what would the mean be? Hope you can see the mean would be 4 because everybody answered 4 questions. You know, mean means if everybody answered the same amount, what would it be? Well, you can even do the math here. If there's 10 people, there should be 10 dots there, 4 questions each, that's 40 questions. So 40 questions divided by 10 is 4. So of course it would be 4. So the mean would be 4. Now can you imagine this? I'm not going to go through all the work, but can you imagine doing that Q minus the mean? Q minus 4. But there's 4s all the way down. So Q minus 4 would be 0 all the way down. And if you squared that, you would get 0 all the way down. And if you averaged that, you would get 0. And if you took the square root of that, you would get 0. There is no deviation. Of course, computationally, you would get 0. But even just conceptually, there's no deviation from the mean. Everybody answered exactly the mean. Everything is clustered. There's no deviation. And so, standard deviation of 0. Oh, we should, just for fun, confirm. Let's make all of these 4s. It's like watching paint dry, isn't it? Oops. All right. Look at that. Mean of 4, standard deviation of 0, of course. All right. Now, I have one more, and that is this one. Imagine 5 people answered nothing, and 5 people answered 4 questions. Let's just think through this a minute and see. Do you think the standard deviation would be more than we've seen or less than we've seen in this case? All right, so 1, 2, 3, 4, 5 zeros. So 0 questions answered. 1, 2, 3, 4, 5 people answered 4 questions. That would be 20 questions total, right? 5, 10, 15, 20. Wait. Just kidding. Just seeing if you're still paying attention. 5, 10, 15, 20, 25. That would be 25 questions total that were answered. Wait, what am I doing? These are 4 questions. 5 people. It is 20. It's getting late at night. All right. 4, 8, 12, 16, 20. There's 4 questions, 5 people. That would be a total of 20 questions answered. All right, but there's 10 people. So divided by 10, it's as if everybody answered 2. If you think about that, if you take, if everybody answered 2 questions, 10 people, that would still be 20 questions total. All right, so a mean of 10. So I'm not going to go through all the details, but I just kind of want you to feel it. So we've got 5 zeros, and we've got 5 4s. So if we find out the difference from the mean of 2, so we would have a whole bunch of negative 2s, 2 below the mean, and a whole bunch of positive 2s. All right, now if you just added those up, all those 5 negative 2s and those 5 positive 2s would add up to 0, so it doesn't help. But if we square that, as we do with standard deviation, we'd have all 4s. All right, so the average would be 4, which would be the variance. And the standard deviation would be the square root of 4, or 2. The biggest standard deviation we've seen, because with a mean of 2, we've got a whole bunch over here, we've got a whole bunch over here. So we're seeing the biggest deviation, and the computer agrees with us. So I entered in the 5 zeros, the 5 4s, mean of 2, standard deviation of 2. So lots of deviation here, because with the mean right in the middle, you've got half the data on one extreme, half the data on the other extreme. We would say that is most spread out. So just to kind of review this one, with the cluster here of at the mean, 4 people just one question away from the mean, and then you got the one on either end, gave us, of what we've seen, gave us the smallest not zero deviation, standard deviation. And then this one with 2's everywhere. Remember, we had a mean of 2, so now only 2 people here. We didn't get that cluster around the mean, and now we've got more people on the extreme, more spread out, more standard deviation. In fact, 1.4 versus 1.095. And then this one, if everybody answers the same, no deviation, no standard deviation of 0, I should say. And then this one, the greatest standard deviation with a mean of 2. Everybody is on one end or the other, so the most deviation, most standard deviation. Hope that helps you to make sense of what standard deviation is measuring by just looking at some specific cases, some specific extreme cases, so you can see what standard deviation is doing.